Good morning. My name is Vishnuvardhan. I am from Electrical and Electronics Engineering. My mpmc tech talk topic is new electronics architecture. System level designing should be done as to provide different services that meet the given requirements of specific application traditionally. Traditionally, two approaches are adopted for engineering design, namely critical engineering and best efforts engineering, which are widely used to facilitate implementation of various applications. Critical engineering design is based on the worst case scenario to meet the requirements in dangerous environments. Best effort engineering design is based on the average case scenario and dynamic resource management. As the processing speed and resource capacity increases, modern system level designs prefer to handle mixed critical applications to reduce cost and enhance system scalability. Handling mixed critical application is a concept that as the process speed and resources capacity increases in system level, handling mixed critical application is a concept that allows applications of different levels of criticals to interact and coexist on the same platform. This paper will study the mixed criticality integration technology for shear systems of commercial airplanes. Avionics full duplex switched Ethernet network has been developed for supporting critical awareness applications such as flight control system, navigation system, and engineering control system. Diverse problems related to these applications have been extremely studied, and the most representative among them include the following: how to schedule and establish the delay of system for the time critical application, how to tighten the bond of end-to-end delay for APDX network, etc. Some problems relating to system level resource management and optimization, however, remains unresolved. For example, experimental studies shows that for providing guaranteed determination to high level criticality, such networks have to be lightly loaded using typically not more than 20% of the bandwidth that the physically link can provide. On the other hand, the same network is also expected to support non-critical traffics relating to file transmission, data backup, system configuration, etc. Providing support to mixed criticality traffic is theoretically challenging but practically useful. In the present work, the emphasis is on system level scheduling and end-to-end delay analysis of both critical and non-critical traffic. Virtual link is a major concept of the AFDX network environment, and it is responsible for routing data flow, translation, and content mining are permitted for academic research only. The VL is a bidirectional logic path based on the physical links. It link on ES to one or no ESS. VLS are rate limited whose dedicated bandwidths are decided by the two parameters bandwidth allocation gap and the largest frame length Lmax ranging from 1 to 128 millisecond in powers of 2. The values of bag provide limited dynamically range for flow control. Furthermore, bag is application specific and is suitable for the role of scheduling parameters in AFDX network. One of the challenges in implementing system level optimization for mixed criticality traffic is providing low latency to critical traffic and simple best effort traffic guaranteed to non-critical traffic. To this end, the compositional scheduling is utilized to serve different types of traffics in different ways. In the scheduler, critical traffics are scheduled by bandwidth allocation gap based on the scheduler and the non-critical traffic by round-robin manner. We propose the flexible system integrated architecture using composable scheduling for APDX network mixed criticality traffic. We exploit network calculus to analysis end-to-end worst case delay for both critical and non-critical traffic. We demonstrate how We demonstrate how to implement the proposed architecture while ensuring latency constant for critical traffic and high bandwidth for non-critical traffic. The remainder of the paper is organized as follows. Related work. In this section, we briefly summarize the existing works on AFDX network and compositional scheduling and highlight the novelty of this paper. AFDS becomes a research hotspot soon after the first place of the network standard. It has been initialized adopted by Airbus Industries for their A330, A380 and A350 civil airplanes and later by Boeing for their Boeing 787 Dreamliner. A lot of work on analysis of network scheduling and end-to-end delays in AFDX network was carried out thereafter. Guttiger et al. Proposed feasible methods for the analysis of response time of network distribution with determinist switch in AFDX, focusing on the design strategies of scheduling methods to reduce end system level transmission jitter in APDX network, optimizes bandwidth allocation gap and frame length size in virtual links, which can address the problem of transmission jitter with a new scheduling policy. Toggle et al. Describes a method to schedule and estimate the delay of end system and time critical application to to accurately to accurately calculate the worst case latency of the given data in a determination routing path. Chiara et al. Presented a limited model checking approach based on time automate, but it is useful only in small example scenarios. The technique based on mixed AFDX architecture presents some functions that are necessary in the gateway nodes to satisfy the end-to-end delay and to guarantee end-to-end real-time communication. To analyze the end-to-end delay of all transmitted flows of AFDS network, George Cameo et al. Proposed a method which focuses on forward end-to-end delay analysis to reduce the permissions of all commutative boundaries, thus facilitating the estimated of end-to-end delay more accurately. Moreover, that the improvement of the reliability of accuracy of end-to-end established. Furthermore, the algorithm adapted for performing end-to-end delay analysis of real-time networking or related system is based on compositional scheduling. It has become one of the most powerful resource management scheduling algorithm for solving the problem of various time critical. All the above mentioned works discuss only one kind of AFDX package. To the best of our knowledge, our present study is the first attempt to integrate mixed critical traffic. In this work, we study end-to-end delay analysis and ensure that non-critical traffics are allocated more bandwidth and the critical traffics are satisfying latency in max critical AFDX network. Completely different from the previous research and the work is specified targeted to AFD because none of the previous works can be directly applied to the AFDX network. Thank you.